This is the second session of physics. Let's understand, children, about the Cartesian sign conventions. In the Cartesian sign conventions, you can see the figure there. It looks like a graph wherein x and y axis is drawn and O is considered as the origin. And same we are going to use in case of a spherical mirror. So in spherical mirror, when we say pole we will consider as a origin. Now we use Cartesian sign convention because we have numericals based on this chapter during that time. This is very important for all of us. So as I said, pole is considered as the origin of the mirror. Let's consider only concave mirror wherein pole is the origin and principal axis is considered as an x-axis. So bring the graph in front of your eyes. Pole is origin, principal axis is x-axis. All the distances parallel to the principal axis are measured from the pole. Okay, now from the pole, all the distances towards the right side are taken as positive, and from the pole, all the distances taken towards the left side are taken as negative. Okay, then you know that when we keep the object in front of the mirror, it is the distance towards the left side. Then the distance measured perpendicular to the principal axis in the upward direction is taken as positive, and the distance measured perpendicular to the principal axis in the downward direction is taken as negative. The object is always placed to the left of the mirror, so our object distance is always negative, and the light from the object falls on the mirror in the direction of the pole. So this new Cartesian sign convention is used in calculating the image distance. We can also find out the object distance. We can find out the focal length. We can find the height of the image. We can find the height of the object, and at the same time this is also useful to find the magnification of the mirror. Children, the next is what is mirror formula for spherical mirrors. So in the Cartesian sign conventions, I was talking about the object distance, the image distance, object height, image height, and focal length. So object distance, the distance at which the object is kept, that is denoted by letter U. The distance at which we get the image from the pole, that is denoted by letter small v, and focal length is denoted by letter F. And the relation between these three, that is image distance, object distance, and the focal length is 1 upon v plus 1 upon u is equal to 1 upon f. And this expression is called as mirror formula for the spherical mirror. Then next we have what is the magnification of the spherical mirror. How will we find out to what extent the image is magnified? So for that we have one formula, that magnification is equal to the height of the image upon the height of the object. Magnification is denoted by letter small m, and height of the image is denoted by h dash. Height of the object is denoted by h. So m is equal to h dash upon h. This formula we will use for finding the magnification. Also, there is a relation between the magnification and the image and the object distance. So how it is related? It is related like this. Magnification is equal to h dash upon h, and that is equal to minus v upon u. So we do not have expression or the derivation for how this formula has come. So we will be directly using magnification is h dash upon h, which is equal to minus v upon u, and this is called as the magnification in the spherical mirrors. So when we will solve the numericals based on this chapter, these two formulas will be very useful to us, and at the same time we will make use of Cartesian sign conventions to solve the numericals. Children, it's now quiz time for all of you. So I want all of you to be ready with a pen or a pencil or a paper. I will flash some questions on the screen. You have to read the question, find out the option and just write the correct option. So here it goes. What is the distance between a pole of the mirror and its principal focus known as? Options are radius of curvature, focal length, principal axis and none of the above. Select the correct answer and write it. Which of the following is focal length of a spherical mirror? Whether it is distance between pole and principal focus, distance between pole and center of curvature, or distance between focus and center of curvature. A, B, C, out of the three you have to select the correct one. Okay, then the third question is, what is aperture of spherical mirror called as? So it's the diameter of reflecting surface of the mirror, or diameter of sphere of which the reflecting surface is a part, or distance between pole and center of curvature. So A, B and C, out of the three you have to think and write. It is what? Aperture of the spherical mirror. Then the next question is, what is the center of curved mirror called as? So four options are there: focus, center of curvature, principal axis and the pole. Then what is called the center of spherical shell of which spherical mirror is a part? So you have to find again the answer: principal focus, center of curvature, pole and aperture. Out of the four, one answer is correct. Just find that and write in your book. So this is your assignment, children. This assignment is based on our today's session, and what all we have learned today. Based on that, you can just make out that I have given you the position of the object in different diagrams, and by using the rules for drawing the ray diagrams, the four rules, you have to complete this diagram. Out of the four rules, make use of any two rules, any two rays to complete all these figures and find out where you get the image. So this is your assignment. Please complete that, and see you all in the next session. See you all in the next class of physics. Till then, goodbye and take care.